Numericals. What is the acceleration of the block and the trolley system shown in figure if the coefficient of kinetic friction between trolley and the surface is 0.04? What is the tension in the string? Take G equal to 10 meter per second square. Neglect the mass of the string. So here the figure shows the arrangement of block and the trolley system. So here the string is inextensible and the pulley is very smooth. So the block and the trolley both have the same magnitude of acceleration. So to find out this acceleration and the tension in the string, you want to apply the second law of motion, because the trolley is moving forward and the block is hanging on the string. So there should be a tension in the string. The 30, that means 3 kilogram, is hanging downwards. The weight is acting downwards. So opposite force, that is opposite to force, tension exerted in the upward direction. And here also 20 kilogram, that is trolley is moving forward. Okay, so a frictional force, a kinetic friction acting in the backward direction, and the tension, that is a force exerted on the trolley that is moving in the forward direction. So this tension and the Fk are equal and opposite to each other, and here the 3 kilogram mass and the weight, that is 30 Newton weight, and the tension acting in the opposite directions. Okay, so before going to do this problem, we have to draw the free body diagram. So when you draw the free body diagram for this trolley, that is mass of the trolley, that is noted as point. Okay, point, and the tension applied, here it is noted as the vector arrows, that is the T, and the frictional force, that is the Fk. Similarly, here also the weight is noted as point, and the that is the mass, that is noted as point, and the weight is noted as 30 Newton, and the tension, that is in the upward direction, that is the T. Then we apply the second law in both the trolley and the block. Okay, so first we have to apply the second law to the block. Okay, so what is the second law? F equal to ma. So F means the total force exerted on the block. So what is the total force here? 30 Newton in the downward direction, that is weight, and the tension, opposite force, tension in the upward direction, that is equal to mass into acceleration. What is the mass here? That is 3 into acceleration you want to find out, isn't it? So F equal to ma, apply here F equal to ma. So that is equal to, what is the net force? 30 minus T, that is equal to mass into acceleration. That is equation number 1. Then apply the second law to the trolley. Okay, second law to the trolley. So what is the net force here? Here what is the net force? T minus Fk. Okay, total force T minus Fk, isn't it? So we can write T minus Fk, that is equal to, what is the mass here? That is the 20 kilogram, isn't it? 20 kilogram. So we can write 20 into a acceleration, that is equation number 2. Then so you want to find out the acceleration and the tension. So what is the Fk here? So you want to find out the Fk. Okay, Fk equal to, what is the formula? Fk equal to, according to law of kinetic friction, Fk equal to mu k into n, where n equal to mg. Okay, so what is the mu k? Mu k is given in the question, that is the 0.04 coefficient of kinetic friction, that is 0.04 into mass. What is the mass here? Mass of the trolley. Okay, 20 kilogram, because Fk is acting on the trolley and the surface. So we can write 0.04 into 20 into g, that is given as 10 in the question. So when you multiply here, it gives 8. Answer 8. Fk equal to 8. Then we substitute here, that is T minus 8 equal to 20a. Take it as equation number 3. Then you should add equation 1 and 3 to get the value of a and t. So we can add 1 plus 3. Okay, 1 plus 3 implies that is minus t plus t, that will cancels. That is 30 minus 8, that is the 22, equal to 3a plus 20a, that is 23a. So, acceleration equal to 22 by 23, isn't it? So, you will get the answer 0.96 meter per second square. Clear? Then you apply this value in any one of the equation and you should find out the value of t. So we can take this third equation because it is very easy for the calculation. So we can write t minus 8 equal to 20 into 0.96. What is this then? When you multiply this, after multiplying this 20 into 0.96, then you add with this 8. Okay. Then you will get the last answer. So 27.20 Newton, isn't it? So this is the tension in the string. Second question, determine the maximum acceleration of the train in which a box lying on its floor will remain stationary given that coefficient of static friction between the box and the train's floor is 0.15. Take g equal to 10 meter per second square. So here you want to find out the maximum acceleration of the train. Inside it, a box lying on its floor and it is remaining stationary. And what is given in the question? Coefficient of static friction between the box and the train. Mu s is given 0.15. So you want to find out the acceleration of the box. That is equal to the acceleration of the train because the box remains stationary in the train's floor. So at the stationary position, the external force acting on the box, that is equal to the static friction force of, that is static frictional force, and it must be less than or equal to the maximum value of static friction. So F equal to that is F, that is less than or equal to Fs maximum equal to mu s n. So what is n there? That is equal to mg. So we can write external force ma less than or equal to mu s mg. So m and m we can cancel. So then we substitute, that is a equal to mu s g, that is equal to 1.5 meter per second square. So this is the acceleration of the box, which is equal to the acceleration of the train because box remains stationary in the train's floor. A car of mass 1500 kg is moving with a speed of 12.5 meter per second on a circular path of radius 20 meter on a level road. What should be the frictional force between the car and the road so that the car does not slip? What should be the value of coefficient of friction to attain this force? So here the car of mass is given 1500 kg and it is moving with a speed of, that is v equal to 12.5 meter per second on a circular path of radius r equal to 20 meter. So you want to find out the frictional force between the car and the road so that the car does not slip. So what is the condition for the car that means the car does not slip? So there should be, that is the frictional force. When the frictional force must be equal to the centripetal force, then the car does not slip. That is the condition. If the frictional force, so we can write the frictional force, okay, I already taught it in the theory, that is frictional force must be equal to the centripetal force. Then the car does not slip from the circular path. So with this condition you can find out the frictional force, that is F equal to mv square by r. Then substitute the values, that is 1500 into 12.5 into 12.5 divided by 20. So when you multiply and divide all these values, you will get the answer, that is 1.172 into 10 raised to 4 Newton. Then what do you want to find out the next? What should be the value of coefficient of friction to attain this force? So here the frictional force must be equal to the maximum value of static friction, that is mu s n. F is equal to mu s n, that is equal to mu s mg. Okay, that is, so you know the F, then you want to find out the mu s. So mu s equal to F by mg. Then substitute the values 1.172 into 10 raised to 4 divided by then 1500 into, we can substitute 9.8 or 10 according to the easiness of the calculation. So after substituting and dividing all these values, you will get the answer coefficient of static friction 0.8. Clear? A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing the speed and without bending towards the center of the circular path. The coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip while taking the turn? So here the question, the cyclist speeding at 18 km per hour, that is the actual speed of the cyclist, and then he takes a sharp circular turn of radius 3 meter without reducing the speed. Then the coefficient of static friction between the tires and the road is 0.1. So you want to justify the answer, well, will the cyclist slip while taking the turn? So first you want to find out, that means you want to write the actual speed of the cyclist. So what is the actual speed? So actual speed of the cyclist, that is given in the question. Okay, actual speed of the cyclist equal to 18 kilometer per hour, then change it into meter per second, that is 18 into 5 by, multiply it with 5 by 18, that then we get to 5 meter per second. This is the actual speed of the cyclist. Then from the question, you need to find out the maximum safe speed of the cyclist. So if the actual speed of the cyclist is greater than the maximum safe speed, then the cyclist will slip while taking the turn. Then you want to find out the maximum safe speed of the cyclist. So what is the formula of the maximum safe speed while taking the circular path? That is V maximum. Okay, maximum safe speed of the cyclist. Okay, maximum safe speed of the cyclist, that is V maximum equal to, what is the formula? Root of mu s r g. Okay, so what is the mu s given in the question? 0.1 into, then what is the radius? 3 meter into 9.8. Then when you multiply and when you take the root, you will get the answer, that is 1 point, that is when you multiply here, you will get, that is root of 2.94. Then when you take the root, you will get the answer 1.715 meter per second. This is the safe speed of the cyclist. Okay, but what happens here? The actual speed is greater than this safe speed. So the cyclist will slip while taking the turn. Okay, so you want to write the last answer. The actual speed of the cyclist is greater than the maximum safe speed. So the cyclist will slip while taking the turn. So you should conclude the answer like this. Clear? A train has to negotiate a curve of 400 meter. By how much should the rail be raised with respect to the inner rail for a speed of 48 km per hour? The distance between the rails is 1 meter. So here the train has to negotiate a curve of 400 meter. Then the outer rail is raised to the inner rail, okay, by a height h. Then the distance between the rails is 1 meter and the speed of the train is 48 km per hour. Then you should find out how much should the outer rail be raised to the inner rail, that is h. You want to find out this h. So speed of the train is V equal to 48 km per hour, then change it into meter per second, that is 40 by 3 meter per second. So from the figure we can write sine theta, that is angle of banking. Okay, sine theta equal to h by L. Okay, h by L. Then you know that for the safe movement of the vehicle without the wear and tears of the tires, then we have the equation tan theta equal to tan theta equal to sorry, v square by rg. Okay, then for the small value of theta, we can write sin theta is approximately equal to tan theta. We can write like this. So we can equate these two equations. That is h by L equal to v square by rg. So from this equation we can write the h. That is h equal to v square L divided by rg. Then substitute the values. What is the v square? That is 40 by 3 the whole square into L. What is the L? The distance between the rails. That is 1 divided by, what is the R from the question? That is 400 meter. Okay, 400 meter into G. You can take the G 9.8 or 10. Okay, then after multiplying and dividing these values, you will get the answer h equal to 0.0454 meter. Clear? So this is the height at which the outer rail is raised to the inner rail. That is h equal to 0.0454 meter.